Alright, I'm back doing some LeetCode stuff. Instead of continuing on the trees and graphs portion, I decided I wanted to do some sorting and searching problems. And I just read this. Seems like they recommend this problem, so let's go ahead and get into median of two sorted arrays. Given two sorted arrays, nums1 and nums2, size of m and n respectively, return the median of the two sorted arrays. Alright. You take the merged array and then you find the median. Okay, so I guess you merge it and sort it and then find the median. Are they already sorted? Yeah, okay, so they're already sorted. Nums1, nums2. Okay, so the overall runtime complexity should be big O of log m plus n. Okay. I'm going to go ahead and guess that you don't have to actually merge the arrays first. I'm going to go ahead and guess that you just have to find the middle and then determine what the middle two numbers look like, and then find the median. Easier said than done, but okay. Try to think through this. So it's log mn. So maybe if you go directly to the middle of each array and determine which one has a higher number, and then using the higher number you could figure out where the actual middle lies. So yeah, so you could start at the center, right? I wish it would have given larger inputs. I'll type some out real quick, just because I think that would be helpful. If we have that, and then we have let's do that. So we could go to the middle of each, and we could determine if we were, I guess, at the median. So that, I guess the hard part's going to be, we're going to have to find where the numbers of both of these arrays collide, where they overlap, and where we'd hit the median. Because if we merged all these, or I mean, so a quick and easy way would be you go one by one, or you loop through whichever the bigger one or the smaller one is, and if sorry, you would need to know, in order to find the median for sure, you would need to know the middle number of the array of length m plus n, which is the merged array. So you would have to do, and I know there's got to be a quick way because they're saying the overall runtime complexity should be log m plus n. But if you did an array, if you went m plus n over 2 iterations and you chose the lowest number out of each array at the time and you just like popped it. So for example, this is how many? 3, 6, 7, 8, and this is 3, 6, 7. So that would be 7 plus 8 is 15 divided by 2. So you would need to go 7.5, so 8. You do the ceiling of 8, and then you would find, for the median, you would find the middle two. You'd find the last two elements, the average of the last two elements for the median. Is that how they calculated that? Between 2 and 3 is 2.5? Yeah, okay. So that's how you could find it at big O of m plus n over 2, which is pretty much m plus n. And that's not log m plus n. So I think in order to do log m plus n, you would have to start at the center somewhere. So I'm thinking, like, if you went to the center of each of these, and you could determine which one is higher or lower, then you could backtrack from there at equal proportions to determine where the median would be, and then from there calculate it. So if you went to the middle of this one, would say the lower portion, you would have 8, and the middle of this one would be 4. And since those aren't the median, we would need, I guess we could divide by 2, we get 5, and then this one we would go up by 2, we would get 6, and 5 and 6 would be close enough in length, right? And that would be 1, 2, 3, 4, 5, 6. Yeah, we would need the 7th and 8th. So 5, 6, 7, 8. Okay, I know I can do it for sure at m plus n, and then I'll probably go back and figure out the shorter timing for it. Yeah, so we'll know. Did they say m was the first array? Just so I can stay consistent. So m is equal to length of nums1 and is equal to length of nums2, and then for I in range n plus n divided by 2. I guess let's do let's do that real quick. We'll do what would this be called? I guess it's not the minimum iteration. It would be like the just half m and n is equal to this. Here's our range. And then we would want to do the ceiling of it. Is half m and n. I guess this would be odd is equal to this mod 2. So if it's odd, this will be a 1. If it's even, it'll be a 2. And then we'll do the ceiling. It's equal to half m plus m. I think it's math dot seal. Is that right? Oh, I was doing JavaScript there. Okay. And we would want to go this many times if nums1. So if the first, why does it keep auto-indenting that much? If the first of this is less than the first of this, then we want to do nums1 dot pop. Holy smokes, why does it keep doing that? Okay, their editor's not as good as HackerRanks is, so that's too bad. Oh. Do the number equals 0. What in the world? Okay, that's pretty annoying. Their editor's pretty bad. We'll have our number equal this. Otherwise, goodness. Otherwise, we want num to equal nums2 dot pop. So this will give us the first element. So whichever one is lower, that's what we want to take first. And we want to take our final array and push num. That will get us our final array. Alright, and then we'll just need one conditional here. So if it's odd, do I print it or return it? Return it. So if it's odd, that means I will have to take the last two of the array. Oh, I forget in Python how this works. I think pop is like, you have to give it the index. Okay, it returns the last item if there's no index. So we need to do pop 0. Okay. If it's odd, we need num1 and num2. And on this one, we will just do the pop. So we get the back 2. And then we'll take the average is equal to num1 plus num2 divided by 2. And that would actually be the median. Otherwise, we will just take the last element. And that's our median. So I guess I can just take this stuff out and return inside those conditions. Let's see if this makes sense before I run it. So they're already sorted, and we can take the lengths of them, the lengths in half, and then the ceiling of that would give us our, so let's see here. We would need 1, 2, 3, 3, 4, 5, 5, 6. That would be our final sorted array. and our median would be 5 and 6, so 5.5. So we would find that by, yeah, so our final array would look like 1, 2, 3, 3, 4, 5, 5, 6. And that's 8. So this was, I think the total length of m plus n here was 15 divided by 2 is 7.5. We take the ceiling of that, that's 8. And if we take 8 of them, and it was an odd number, oh no, I think this might not be correct. If we divide it by 2, no, because this is half m and n. So I would need to take mod 2 of m plus n. And then I would want to take the ceiling of half m and n. So that's correct. This part's correct. So I needed to change this calculation, take the ceiling, or the mod of the addition. I'll change this into a plus. Half of m and n. I mean, I guess I can change this all to pluses, make it a little more readable. Okay, there we go. All right. So let me finish out what this array would look like. We have 2 6s, 7, 2 8s, 9, a 10, a 14. So walking back, we have 1, 2, 3, 3, 4, 5, 5. This is the middle. Is that correct? So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. So did I miss a number in here? Or did I miscount earlier? I might have miscounted earlier. That's 8. That's 7. So there are 15. Okay, so this is incorrect. So if there are an odd number of numbers, if m plus n is odd, we just take the last one, right? We would have taken half of it plus 1, so it would have been half of it plus 1, so we would just take the last one. Okay, so this is incorrect. This all needs to be resorted. So if it's odd, you just take the last one. If it's even, you take the final two and then take the number of it. Okay. Let's see if this worked. Even though I know it's not log m plus n. Oh, whoops. This doesn't have push. Is it add? Append? Guess I should run it before I submit it. Is it still saying the push thing? Did it not rerun? Maybe it didn't rerun. Ah. num2. This needs to be nums2. Whoops. Ah, okay, so one of them ran out of indexes before the other one did. So in that case, I would need to find Well, let's see. If the length of nums1 is greater than 0, or I guess is equal to 0, then we know that num will be equal to nums2.pop. And vice versa. Nums2 is out of indexes, then we know it's got to be nums1. So if the input is 1, 3, and 2, half of n plus n would have been 2, would have been 1.5, and the ceiling would have been 2. So for 0 and 1, I guess this could be that. Oh, oops, I need my ellipse. Okay. My answer was, I wish I could get rid of that. Oh, that was a submission error, that's why. My answer was 3, and the expected answer was 2. Oh. Okay. I would like to know what the final array looked like. I had all of them in there. So that's interesting. It should have been 1 plus 2 divided by 2. Aha. I put parentheses around everything except that one. That was my fault. Let's submit it and see if it goes any better. Nope, I got the wrong answer. So something was incorrect with what I did. Let's run through what this looks like real quick. Okay, we have half of m plus n, looks like 2. We have ceiling of half m plus n, so I had 2. And that's probably why. So it should have, if it's odd, I just need the ceiling. If it's even, I need half of m plus n plus 1. Because if it's even, I would have needed 2 and 3. Then I combine those, and I'm going to assume that this logic was correct. So instead of doing this, I'm going to have to do one of these up here as well. I need, is that used anywhere else? No. Okay. I need to cut that. I need to do iterations or minimum numbers needed. I'll start off with actually I'll start off with this. No. So if it's If it's even, I need an extra number. If not, I just need the ceiling. Let's make sure that that even runs correctly. Okay. That ran correctly. Float cannot be interpreted as integer. If it's... What? If it's odd. Okay. Well, maybe it doesn't work like that. If mod if the mod is equal to 1, that means it's odd. But it doesn't seem to want to run that. Minimum numbers needed. If it's the ceiling, it should be an integer. Otherwise, it's okay. Well, quick and easy solution is just to print it out and run it. And then try to figure this out. So this would have to be, if this was even, this would be 0. And if it was even, this would be a whole number, which means that that should be a whole number. My standard out is 3. Okay. I guess because I divided it by 2, it converted it to a float. Huh, how interesting. Well, that was accepted. I wish I knew. Okay. Well, I guess a lot of people didn't go for the... Okay, so that was the right solution, at least. I guess my runtime... That looks like what a majority of people did. It looks like not everyone went for the log of m plus n. Yeah, it looks like I bet most people went for the same solution that I did. So, alright. Well, there you have it. I guess that's the not the big O of log m plus n solution for this algorithm, but it is one way to do it.